All right, let's talk about derivatives of some trig functions. Now, I'm going to give you a bunch of these, or some of these, without proof. This first one can actually be proved geometrically. I'm not going to go through the proof for you here. I just want you to believe it. You can look that up if you want. It's even in your book. The derivative of sine of x is cosine of x. The derivative of cosine is negative sine. It doesn't just go back. You got to memorize these. Like, I'm going to give you a formula sheet for test 2 with some of the inverse trig functions. These two you got to memorize. Derivative of sine is cosine. Let's look at a picture and motivate that. But this is not a proof. This is just a motivation. So this graph here is the graph of sine of x. Remember what the derivative is. The derivative tells you whether you're increasing or decreasing. The derivative tells you whether your tangent lines are positive, negative, or 0. So in this region of sine, from 0 to pi over 2, this value right here, pi over 2. In that region, sine is going up, it's increasing, but the tangent lines are getting less and less positive. Like right here, my tangent line is pretty steep. But by the time I get over here, my tangent lines are less steep until I get here when my tangent lines are 0. So here m would be like 0. Here m would be like 0.1. And there, my slope might be like 1. So all the derivative values are positive, but getting less and less positive, getting closer to 0. Right there. That would be a graph of the derivative. So here's the original function. This dashed line is his derivative. Notice I hit 0 right there. So look, all these derivative values, they're all positive, but they're getting less and less positive as I go from left to right. Okay, now what about during this orange part? My function is decreasing. Remember, if your function is decreasing, your derivative is negative. Increasing, positive derivative. Decreasing, negative derivative. So the function's decreasing. Sine is going down. So all my derivative values have to be negative for this entire region right here. Negative derivative. Starting at 0 and ending at 0. See, my slopes here are 0. So the derivative will be 0. Okay, look at this graph here. These are all negative values. So like right there, my derivative might be negative 0.5. And then right here, my derivative might be negative 1. Oh, but see, now we're back to like negative 0.5, negative 0.1, negative 0.01, 0. Look at all these values. So getting more and more negative, getting less and less negative. And then during this region, here's my original. This is sine of x. The function's going up. Look, from left to right, I'm increasing. That means a positive derivative. Here are my derivative values. We're going to spend a whole lot of time on curve sketching, where we take a graph and we sketch out his derivative, or we take a derivative and we sketch out a possible graph. We're going to play with going back and forth, but make sure you kind of understand what I did here. So this was sine of x here. This graph here that I just claimed was his derivative, that's cosine of x. So the derivative of sine is cosine, and then the derivative of cosine is negative sine. You pick up a negative when you take the derivative of cosine. Okay, and now let's just do a bunch of examples based on those. So here I've got a product. This will be a product rule. So here's function number 1, here's function number 2. The derivative of a product is take the derivative of the first times leave the second alone, plus Derivative of the second, the derivative of sine is cosine, times leave the first alone. And maybe that would be better to write as 15x squared sine of x plus 5x cosine of x, 5x cubed. But either way is fine. Okay, what about here? Here I've got a quotient. So this is my top and the bottom. Then the derivative of g here will be derivative of the top. The derivative of cosine is negative sine of x times leave the bottom alone minus take the derivative of the bottom times leave the top alone all over the bottom squared. And maybe we could clean this up. Maybe that would look prettier if I wrote this as negative 4x squared sine of x minus 8x cosine of x all over, what would we get here? 16x to the fourth. But either way is fine. Like the homework will accept it when you type stuff like this or like this. Okay, that's a good place to stop here.